Now we want to talk about graphing these parabolas of quadratic functions with horizontal and vertical shifts. What do we mean by that? Basically, we mean that you can take a graph of a parabola and you can move it up or down as a vertical shift, or you can move it from left to right in a horizontal shift. So the first thing we want to talk about is the vertical shift of a parabola. So let's see what exactly do we mean by that. Now the vertical shift basically is if you have the graph of f of x equals x squared plus h. So basically if you take your basic x squared graph and you add a constant k to it, it would still be a parabola with the same shape as the graph of your x squared function. The only difference would be now, since you're adding that plus k to it, that the parabola will be shifted k units up if the value of k is greater than 0, which means if k by itself is a positive number, your graph will be shifted up k units. And if k is a negative number, which means if k is a negative number and you add a negative number, you will be moving k units down. And we're looking at this in terms of absolute value, because when you move down, you're already taking into consideration the negative sign. So whatever the absolute value of k would be, that's how many units you would shift down. And of course, since your graph will be moving up or down, your vertex is going to change. It's not going to stay at 0, 0. And your new vertex would be 0, k. Okay, so by how many ever units you move up or down, your y coordinate in that vertex will be changing also. So we want to see how exactly would this vertical shift work for us. So let's take a look at this example here. We want to try and graph these functions. You have x squared, you have x squared minus 3, and you have x squared plus 2. So we're trying to graph these f, g, and h functions. You can see one example is just the basic x squared function. The other one, we have a negative k, and in the last one, we have a positive k. So again, remember, positive k should take us 2 units up because it's a positive 2, and negative 3 will take us 3 units down as per our vertical shift here. After we're done graphing, we're also going to try to find the vertex, the axis, the domain, and range for each of these functions. So let's start with our f of x equals x squared function. Okay, and we'll go ahead and make a t-chart for it. Okay, now we already graphed this function before, so we'll go ahead and use the same points that we had used earlier for these: 0, positive 1, negative 1, positive 2, and negative 2. Okay, and your corresponding values were 0 square is 0, 1 square is 1, negative 1 square was also 1, 2 squared we know gives us 4, and negative 4 squared will also give us 4. Okay, so we'll need these points to graph our f of x function. Now let's try and find points on the g of x function, which is x squared minus 3. So again, you want to try and find at least maybe 4 or 5 points on that. And we'll try using the same x values: 0, 1, negative 1, 2, negative 2. Now, there's no restrictions on what x values you want to use. You can use something else. If you want to use 3, negative 3, 4, 5, negative 6, it's up to you. This was just what my preference was. You have your options open. Okay? So again, let's see what happens when we put x equals 0 in our definition here. So 0 squared is 0. So 0 minus 3 will give us negative 3. Okay, what happens when you substitute 1 in your equation? 1 square is 1. 1 minus 3 will of course give us negative 2. Okay, you want to try and do the same thing with each one of these points. Negative 1, again negative 1 square is 1. 1 minus 3 gives you negative 2. Plug in 2 for your x. 2 squared is 4. 4 minus 3 will give us 1. Okay, now negative 2. Negative 2 squared is 4. 4 minus 3 will of course give us 1. Okay, so we got our t-charts for f and g functions. Now we are left with h of x, and h of x function is x squared plus 2. So we're trying to find a t-table for that. And again, we'll just use the same x values, 0, 1, negative 1, 2, and negative 2. Again, we'll do the same thing. Take these x and substitute in your h of x definition. So 0, x equals 0 will be 0 square, which is 0 plus 2 will give us 2. Let's plug in 1. 1 square is 1. 1 plus 2 gives us 3. Same thing will happen with negative 1 squared will give us 1. And again, you end up with 3 as your y value. Right? Let's see what happens with 2. You have 2 squared, which gives you 4. And 4 plus 2 will give us 6. And again, same thing. Negative 2 squared gives you 4. And you'll end up with 6 as your y value again. So since we're trying to graph 3 functions here, you need 3 t-charts for it. And let's go ahead and graph this on the same coordinate plane, just so that we can see what happens when you have your base function x squared. What happens when you shift it 3 units down and you shift it 2 units up? What will that change look like? So we need these t-charts to help us out. And this is our coordinate plane that we're going to try and graph this on. Okay, so we'll start with our x squared function, our f of x function. So we've already graphed this before, so you know what that's going to look like. You have your 0, 0, which will be at the origin, 1, 1. Okay, we'll call this 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. So we'll leave every alternate one just so that our graph looks a little better. So now you have 1, 1, which would be right here. Negative 1, 1 would be right there. 2, 4, so that's 2 and 4 would be right here. Okay. Negative 2, 4 would be right about somewhere here. Okay, 1, 2, 3, 4. So go ahead and graph these. This should be a curve that looks something like this. And you can see I've made it a little wider just so that we can see it better. And it still has that distinctive parabola shape. So this was your f of x function. Okay, we'll go ahead and name it so that we know which graph stands for what function. Now we'll move on to our g of x, x squared minus 3 function. You had 0, minus 3 as your first point. So 0, negative 3 would be right here. Then for 1, you had negative 2. So that point would be right here. Negative 1 was also negative 2. So that point would be right about there. For 2, you were at 1, so 2 and 1 would be right here. Negative 2 and 1, that point will be right there. So again, if we try to connect all these points, this is what you will see your graph looks like. Okay, and this was your g of x function. So you can see when you started from x squared and you went down to x squared minus 3, we shifted our graph 3 units down. Your origin, your vertex was at 0, 0, and now you went 3 units down, so your vertex also shifted. Okay, now let's try and graph our last function, which was h of x, x squared plus 2. And let's see what that will look like. So you have 0, 2 as your first point, so that will be right here. You have 1, 3, so 1 is right at 3. -1 is also at 3. 2 is at 6, so 2 will go up to right here. Okay, 2 and 6, and -2 is also at 6. So -2 and 6 will give us something right here. Okay, so if you again connect all these, you can see that this graph will have moved 2 units up because you had a +2 as your k constant. And this is your h of x function. Okay, so again, comparing it with your base function x squared, when you have x squared plus 2, just by adding that 2 on your x squared function, you moved 2 units upwards. Okay, so that's what that vertical shift is all about. Depending on what kind of a k constant you have, if the constant is negative, you go down. If the constant is positive, you go up. Now, they also asked us to find the vertex, axis, domain, and range for each one of these functions. So let's go ahead and determine those values. Okay, so we'll keep our graph here. We need to find the vertex, we need to find the axis, and we're also trying to find the domain and range for each one of these functions. Okay, so we'll start with the f of x function, then the g of x, and then our last h of x function. So we'll start with the vertex first. Again, remember, vertex is the lowest point on the graph. So for your f of x function, which is in the middle, your vertex is at the origin. That's the point 0, 0. Your g of x function is the one below our f of x. And you can see that you have gone down to 0, -3, because that's what your k value was. It was -3. Okay, and then for your h of x, this is your vertex, which is moved up 2 units from the f of x function, and so your vertex here is going to be the point 0, 2, and again you can see that 2 was the k constant on your function definition. Okay. Now we want to talk about the axis. Again, remember, the axis is the vertical line that goes through the vertex of your parabola. Now, if you look at all 3 of our graphs, you can see that their vertex are all lined together under the same column, so they all share the same axis of symmetry, and you will see that your axis of symmetry is the y-axis itself, and the equation for the y-axis, of course, is x equals 0. So all the 3 graphs have the same axis of symmetry. Now, if they move left to right, the axis of symmetry changes, but when they're going only up and down, the axis stays the same. Again, if you talk about the domain for each one of our graphs here, again, you can see that the domain is going to be -infinity to +infinity, since we are covering all the points on the x-axis. Now, your range is going to change for each one of these functions. Now, of course, for your f of x equals x squared graph, your range is going to be from 0 to +infinity, because you can see that we're starting at the point x equals 0, y equals 0, or the origin, and we're going all the way up. Okay, there's no part of the f of x graph below the x-axis, so your domain range for f of x is 0 to infinity. If you look at your g of x graph, this graph starts at -3 on the y-axis. There's no graph below -3, but you start at -3 and you're going all the way up. So in terms of your y-axis, so your range will start at -3 and go to positive infinity. Similarly, if you look at the h of x graph, which is this one right here at the top, you can see that we're starting at y equals 2. With respect to the h of x graph, you don't have anything below 2 on the y-axis, so you start at 2 and you're going up to all the positive side. So in this case, your range is going to be 2 to positive infinity. So in this example, of course, you can see how the vertical shift occurs when you add or subtract that value of k. Again, if k is negative, you will shift down. If k is positive, you shift up.